Hi, this is Dr. S, and this is my 11th video in my series on reaction rates for Year 13 A-Level Chemistry. This video is about the rate determining step. Now, this is the term given to the slowest step in a multi-step reaction. So what multi-step reaction means is that it has a reaction mechanism. We've seen reaction mechanisms in organic chemistry. Here they're going to look more simple, but it's still stages of a reaction. So if I draw the mechanism of a simple reaction, let's say that the overall reaction that's going on here is A plus 2B makes C plus D. That's the overall. And I'm going to split it into steps. So that's the overall. So my steps have to add up to the overall equation. Well, let's say my steps are A plus B makes C and another thing called E. And then the second B reacts with your E to make D. And hopefully you can see that if you add those two steps up, it adds up to the overall. Because the E cancels itself out. The E is produced and then used up. The term for that is the intermediate, which again you'll have heard the term before, but that's an intermediate in this reaction. So there are two steps here. So let's look at two possibilities, one in which the first step is the slowest and one where the second step is the slowest. And we'll see how it affects the rate equation. So let's start by saying that this first step is the slow step, and we'll say that the second step is fast. What that means is it's this one that determines the rate of the reaction. A reaction can only go as fast as its slowest step. This one was fast, that doesn't really affect the reaction rate at all, so it's this one that determines it. So it's the species in the rate determining step that appear in the rate equation. So in this example, the rate equation will look like this. Rate equals K A B. Note how I've only got one A and one B, not two B's. That's the overall. The species that appear in the rate equation are the ones that go into the rate determining step here. So 1A and 1B. We ignore this B because it's in a fast step. Now let's look at the other possibility where the second step was the fastest. So A plus B makes C plus E again, and then B plus E makes D. So the same mechanism, but this time the first step is fast and the second step is slow. So we'll look at how we make the rate equation. Well, the rate equation contains the species in the rate determining step. So that means we want the rate equation to look like this. Rate equals K, B, E. That's what it looks like it should be, because we've got a B and an E in the rate determining step. Now the problem is, E is an intermediate. We can't put the concentration of an intermediate because we can't measure that concentration. It's used up, it's produced, and then it's used up. We cannot measure that concentration. So we need to replace the E with things we can measure the concentration of. So how we do that is look at what made the E in the first place. Well, the E was made from an A and a B. So that means my rate equation, if I look at my work in here, the rate then becomes K, the B stays as it was, but the E changes into an A and a B like that. So now if we make these into alphabetical order and square the B's, it becomes rate equals K A B squared. Okay? So really, to summarise that, the rate equation contains the species up to and including the rate determining step. Okay, so I'm going to put some examples on the screen for you to have a go at. The reactions in purple at the top are the overall. So it's two separate reactions, so we'll draw a line down the middle to show it's separate. These are the overall equations. And these are the mechanisms. So I've done exactly the same mechanisms twice, so you can test your skills with both of them. So on the top, I'm going to ask you to come up with the rate equation if the first step is the slow step. And similarly here, if the first step is the slow step. And on the bottom half, if the second step is the slow step. So the asterisk means the rate determining step. Okay, so the rate equation for each situation, please. Come back when you're ready. Okay, so we'll start on the left hand side. Here, the rate determining step contains one F and one G. So the rate equation would be rate equals K, concentration of F, concentration of G. Here, the second step is the rate determining step. So we want it to look like rate equals K, J, G, but the problem is that J is an intermediate and cannot be used in the rate equation. So we have to substitute J with what makes the J, which is the F and the G. So rate equals K, the F, the G, and then the other G. So overall, rate equals K, concentration of F, concentration of G squared. So the bottom line is the correct one. On the right hand side, first step. When it's the first step, it's relatively simple. So rate equals K, concentration of K, concentration of L, because it's one of each. In the second one, we want it to look like rate equals K, K, O, because it's a K and an O, but the O is the intermediate. What makes the O is a K and an L. So we swap the O for a K and an L. So then the overall answer becomes rate equals K, concentration of K squared, concentration of L. So I hope that made sense. In my next video, we will look at how to develop the mechanisms from the rate equation and the overall, which is quite tricky, but I'll see you then.